And finally, question B12. It reads, a student investigates the rate of the reaction between magnesium ribbon and 1.0 molar hydrochloric acid. The equation is Mg solid plus 2HCl aqueous gives MgCl2 aqueous plus H2 gas. The volume of hydrogen gas produced is then measured at regular intervals. Part A says, draw the experimental setup that would enable the student to measure the volume of hydrogen at regular intervals. Let me describe this diagram step by step so you can draw it clearly. Draw a conical flask sitting on a bench. Inside the flask, draw a piece of magnesium ribbon and show liquid to represent the hydrochloric acid. Fit a rubber bung or stopper tightly into the top of the flask so no gas escapes from the top. From the bung, a delivery tube leads out and connects to a gas syringe positioned on the side. Label the contents of the flask as magnesium and 1.0 molar hydrochloric acid. Label the gas syringe. As hydrogen gas is produced, it pushes into the syringe and the plunger moves outward. The volume is read directly from the syringe at regular time intervals. Part B says, the following data was obtained. Time in minutes 0, 1, 2, 3, 4, 5, 6, 7. Volume of hydrogen in cm cubed 0, 14, 23, 31, 38, 40, 40, 40. Part C, Part 1 says, plot the results on the grid provided on page 18. Label the horizontal axis as time in minutes going from 0 to 7. Label the vertical axis as volume of hydrogen in cm cubed going from 0 to 40. Plot each point carefully using a pencil. Then draw a smooth curve that rises steeply from 0 at the beginning, gradually slows between minutes 3 and 5, and then becomes completely flat at 40 centimeters cubed from minute 5 onwards. That flat horizontal line shows the reaction has stopped because the limiting reactant has been fully used up. Part C, Part 2 says, explain how the rate of reaction changes with time. At the start of the reaction, the rate is fast because the concentration of hydrochloric acid is high. This means there are many successful collisions between acid particles and magnesium atoms per unit time. As the reaction proceeds, the acid is gradually used up, so its concentration decreases. Fewer successful collisions occur per unit time, and the rate of reaction slows down. Eventually, the rate becomes 0 because all the hydrochloric acid has been completely used up. Part C, Part 3 says, sketch on the same grid on page 18 the curve obtained if 0.5 molar hydrochloric acid was used instead, keeping the quantities of the reactants constant. The new curve starts at 0 on the same graph. It rises more slowly and less steeply than the original curve because the lower concentration means fewer collisions occur per second, giving a slower rate of reaction. However, the curve must eventually reach exactly the same final volume of 40 centimeters cubed. The reason is that the same quantity of magnesium is present, and magnesium is the limiting reactant. Only the rate changes, not the total amount of gas produced. Draw the new curve below and to the right of the original curve, flattening out later but finishing at the same height of 40 centimeters cubed. That gives you your 10 marks for question B12. And that completes the entire paper. And that is a complete revision walkthrough of the Chemistry GCE Paper 2 from August 2025. We read every question exactly as it appeared on the paper and explained every answer in detail. Go back and replay any section you found difficult. Focus especially on the particle diagrams, the half equations for electrolysis, and the mole calculation steps because those are the areas where most marks are either gained or lost. Work hard, stay consistent, and I will see you in the next one.